In this video, we will talk about a couple of things to wrap up the chapter. One is EDCA and the other is the concept of block acknowledgement. EDCA is nothing but enhanced distributed channel access. Enhanced distributed channel access. Now EDCA is an extension of DCF, which we heard about or talked about in the last few videos. This is basically differentiating the users based on their user priority. It's more like you can talk about QoS here. It's a part of the 802.11e amendment, which is also another word for QoS in wireless. Okay, so there are 4 different access categories. One is background, the other is best effort, then we have video, and then we have voice. So based on these 4 user priority or access categories, the traffic is kind of prioritized in Wi-Fi as well. Okay, how it really works is, since it is an extension of DCF, they have to go through the contention mechanism where they go through nav and random backup timer. But based on the priority of the traffic coming from the backend, let's say it's a voice traffic, how it helps in Wi-Fi is that the backoff timer that we talked about in the last video, okay, for a prioritized traffic, this backoff timer is low, is very less. Hence, the RBT of a prioritized traffic is very less. So it's likely that it will win the contention when it competes with the other clients with normal traffic, right? I'm trying to explain this in the easiest possible way right now. So we don't need to go into too much details around this, but the 4 categories for QoS in Wi-Fi are background, best effort, video, and voice, based on the user priority that it is coming with from the backend. And during contention, the last timer that the client has to go through is RBT. RBT is a combination of backoff timer multiplied by slot time, right? So this backoff timer is controlled by, QoS is a contributing factor to this backoff timer. If we have a traffic coming with the priority of voice, then backoff timer is going to be reduced, which means the complete RBT is also reduced, and hence it is more likely to win the contention contest, and then it's more likely to pass traffic before any other client. That's how it gets priority. Okay, that's EDCA for you. The next thing that I want to talk about is BA, which is also called as block acknowledgement. This is also a part of 802.11e amendment, which is QoS. This is the purpose of this block acknowledgement is whenever a client, let's say client number A, wants to send some frames to client number B, instead of sending one frame and then waiting for the acknowledgement like it usually happens, frame number 1 and then you get an ACK, then frame number 2 and then you get an ACK. Instead of this, what it does is, in .11e, the client will send back-to-back QoS frames to the receiver, 1, 2, 3, and then it will request for a block ACK request it will send. Now, instead of acknowledging every frame one by one, the recipient, that is B, or the receiver, that is B, will acknowledge all the frames together and send a block ACK for all the 3 frames. So now A knows that, okay, all my frames were received by the receiver B. It doesn't have to retransmit. This is a good thing because it's going to save a lot of time, and it's kind of going to speed up the entire process of frame transmissions. So QoS helps with EDCA and block ACK, and there are some other things also which we will discuss in the following videos. But for now, EDCA and block ACK is something which you should know. We'll continue with the next chapter in the next video. Thank you.